Dr. Carola Lilienthal is a speaker at various conferences. For example, the IPC conference last year in Munich. And she's speaking a lot about software architectures and technology. And Wolfgang is head of software development at Sixt, and he's also enthusiastic about good architecture. So, thanks a lot.
So maybe I start where Jochen with his introduction finished. So he was talking about the different types of mobility Sixt is offering. And you have seen one talk coming from Sixt Rental. The second was from Drive Now. And my part now is from Sixt Leasing, one other company in the Sixt group. I'm head of software development, and I'm really happy to talk with Carola. I think our last talk we had together was about 20 years ago. So we know each other for a very long time.
We were in California.
Yeah, that was actually my first English talk. The topic is really, today it's language dependent because all the examples we will give are related to PHP. In general, it is not that much language dependent. Because good architecture is good architecture, whether it's Java, PHP, COBOL, whatever. And the reason why I actually started with architecture investigation at Sixt is, you will see that from one of the upcoming slides, that I'm responsible for an area which is not that modern and fancy from the beginning. So 70% of the code I'm responsible for is COBOL. Then there's PHP, and now a very small part of Java. But it has an architecture, it obviously had a structure, and we somehow had to discover what is in there, how it is related, what are the modules, how are they interconnected, and so it's somehow grown, and that's actually one of the main reasons to look at technical debt. You see the short comic here. You already see there's kind of layering, and the upmost levels, they don't have really good names related to what the levels are responsible for. So it's very typical that you run out of names and just name them after the fancy architect. You will find that in our systems too. So, Carola?
Oh, it's you now.
It's me. Oh, we changed the slide order. Okay, once again. This is not a commercial slide, it's the motivation why we go in here. So Sixt Leasing has different business areas. We started a long time ago, actually 50 years ago, with leasing, fleet leasing. We added kind of later fleet management, which does mean we run fleets on behalf of our customers, but we don't own the cars in any sense. And then we have a brand new business, and I think 3 of the developers are also now here in the audience, which is online retail. That does mean sell, lease contracts over the internet. That is actually built on a complete PHP stack. Everything which is on the left side is pretty much old. And what you can see, the right side here, that is this one. That is the most growing business we have. That's what we have to look at and take care for the architecture.
Okay, hello from my side as well. My name is Carola, I'm from Hamburg, and I'm working in a company of 60 software developers, software architects, and my job is the architecture section in our company. We do as well requirement engineering, and several of our people love to build fancy and interesting software for Hamburg Harbor and so on, but my job is to fly around Germany and have a look at large software systems. So in the last 10 years I've been looking at about 100 different software systems, many Java systems, C#, PHP, whatever you can find in this world where people have problems with costs running out of scope, and it costs more and more to change the software system. So this is what I'm doing in my daily work, and what Wolfgang and I will show you today is what you can see there, and I will try to give you some background on what do I look at when I look at software systems, what do I tell people to do, to change in their system. And you will start with a cool, another slide of mine.
Yeah, pretty rough overview. That's an architecture overview. Interestingly enough, that is a slide our CEO is using when going to banks and asking for money. So he's presenting something like that. And that is one view to our system architecture. Actually, it's pretty new. So last year we went public to the stock market, and we actually started to explain why we are in the heart somehow a software development company, and it is a key advantage for us to have the whole development lifecycle and all components in our hand. So what you can see is that our architecture compromises a lot of processes somehow. These are in the end implemented processes, then processes on a second level, and that's always across the value chain of our leasing business. And then a pretty high number of different services. And when I started, so I'm at SIX now for 2 years and 3 months, we didn't have that. We had a rough idea of different business areas, but we have the idea that when we want to provide those processes to the outside and do business process outsourcing, then somehow like that, our infrastructure should look like. So we had a target architecture. And of course I had to do some archaeology or investigations on the existing systems and see how they look like. And about 2 years ago, I came in touch with the PHP community first time at PHP conference in Hamburg, unconference in Hamburg. And I was used, so coming from the Java world, was used to a lot of nice tools for investigating the architecture, drawing nice pictures of the architecture, being able to do refactorings, all that stuff. And I was somehow shocked at that conference because it seemed to me not to be professional what we were talking about at the unconference. But that was the first time I came in touch with the PHP community. So what we did, actually, the whole stuff here, the whole quoting, is completely rebuilt for 6.9. So it does mean web UI, back office software, then all the services used for that, the processes using this, and the top level process. That's all rebuilt, but somehow has to be connected to all the rest, because we didn't want to build everything from scratch. So one thing is investigate how does the current system work. Second is find the right way to connect it to the current system and to replace what we need for the new business, because it looks dramatically different than what we had before. And I have to admit, in the meantime, I'm convinced that PHP developers are real developers and professional developers. I was attending the Symphony conference last year in Berlin, and that was a professional software development conference compared to the other. So that's what we are looking at from the business side. And now Carola will show how to, I go to the next one. We will show with tools how to achieve that. So what you always see is like what we show in this comic. Someone wants to look at your architecture, stating, didn't you say this system had a nice and clean architecture? Of course. Once again, look into it, and statement will be, you cannot see it at the moment, because it's hidden behind the code. And there's a number of developers telling, the real architecture you only find in the code, nowhere else. Yes, true. It's everything which is implemented really is in the code. But if you don't have an idea what the model should look like, you never have a chance to prove it. You will never have a chance to refactor, and you will sum up high level of technical debt. That's unfortunately the truth. So what happens? You don't have a model, or maybe you even have one. You have some restrictions that you cannot invest that many in building the right stuff, improving your architecture, and if it's really going wrong, so I have to admit, we definitely work in sprints. We want to deliver every 2 weeks, so that's how 6 is working. We're doing that for COBOL code, PHP code, Java code. It's 2 weeks release cycles. So throughout the whole organization. The goal definitely is we keep our architecture, we keep the quality, we reduce the technical debt after every sprint. That's the goal. Then you have some business reasons. You have maybe lack of skills. There are reasons why the target implemented software looks different, and why what you really, so the time or outcome per time really reduces. You build up technical debt. And if you then don't take time to go back, refactor, take out the stuff which is not intended to be in your architecture model, you will end up there. So continuous refactoring, it's definitely a must. But if you don't know where to go to, what are you aiming for, what is your target model, that's really difficult to achieve. So what is the plan? Of course, have regular architectural discussions. To be able to have that, you have to have real models up front, something you can compare against. Where do you get that from? Somewhere there must be a way to create the models out of the real code. You constantly need to qualify your developers and architects to be able to talk about that. It's not that easy, and not every developer's favorite task to go to a whiteboard, sketch the architecture, and discuss it. So sometimes it's really just he doesn't have the skills because he never learned it. Sometimes it's impossible to depict what is really in the code because no one understands the real model. So that is something you have to qualify your people for. The next important thing to be able to measure against the technical debt is continuous automated tests, so you can actually do refactorings. I think everyone knows that. Good question is, are you doing that for all of your code, even for your legacy code? And to be honest, there's no reason to say it's impossible. So looking back at the last 2 years, we are able to do unit tests for COBOL code. No problem at all. It's possible. You just need the will and the education to do that. And of course, the next one is, or the most important, you have to regularly invest on architecture analysis and renovation. It will go into the wrong direction. There's always some kind of pressure. There will be good reasons why you have to bring the newest version out to the market, but you have to be aware of what the problems are.
So what do I do when I get into a company and they ask me to look at their software architecture? Well, the first thing is I ask them, well, what is your planned architecture? Do you have a diagram? This is what Wolfgang just said. And often there is one, looks something like this, some layers, some modules, classes in their packages, namespaces. I don't know what you use to indicate in your source code that there is the architecture, but you have namespaces and directories in PHP, so you can do that as well. And then I try to compare this plan with the actual source code. And it never fits. I mean, this is what I can tell you right away. It never fits. The normal thing is that people are implementing their source code, implementing, and they don't remember about the plan. They don't see it actually in their classes or in their files where they are programming. So they forget about the overall idea. And I have never seen any system where the source code was really conforming to the planned architecture. So this is very normal what happens. And what I'm doing now, what I'm doing then with the people is I'm working on their system. You want to say?
But you have to have a plan. Really important.
Yes. Without a plan, I can do some analysis too, but it's more something like architecture, archaeology. You know, I'm digging in the source code. I'm trying to find out what someone might have been thinking. So it takes much more time. So a plan is a good idea, and even if the plan and the source code don't go along, we're going to find a way to get them to go along. I will show you in a second. So we have the source code and the plan, and we try to reconstruct the architecture from there. And then what is the most fun part of the whole thing is to discuss the results with the team. So you all know pair programming, I guess. Do you? Do you also know mob programming? Yes, some people are nodding. It's a new idea. I mean, not so new. It's out there since 2 or 3 years. The idea is that the whole team is sitting in front of a huge monitor, and someone is having the mouse and the keyboard and is programming, and everybody is talking in a team about what's happening. Is this a good idea? Should we do it differently? So pair programming with the whole team, we do it in our companies very often, and people really love it because the whole team understands what's going on. With big refactorings, it's a very good idea. And what I do is I do mob architecture analysis. So I don't go into some room alone with the system and look at it, but I have the whole team with me. Look at the system. We model the architecture onto the source code, and we discuss what we find all together. And this is the fun part of the whole thing, because of course we find things that are not good, violations. But we find refactorings, we find very quick refactorings. I will show you in a second how this works. And we can start to discuss alternatives for the architecture, for the chosen architecture. And this is what people really need. If you are working in a team and you are creating some system over years or even over months, you need a regular possibility to discuss what the whole team is thinking about the system, how it should be built. And this is what can happen in such an analysis.
One thing about the violations. Violations are not always bad, right? So I have to put my manager hat on. I have to develop in-house software. I never will ship that software to customers outside our company. Of course, there are websites the end users will use, but it's our software. We decide when we deploy, where to run it. So there can be violations, but I have to be aware of those. So they have to be documented. There's a risk behind. The risk has to be measured or quantified in some way and put down. So together with the latest implemented architecture and what came out of the analysis, you have to note down what the risk is and who decided to accept that risk.
Thanks for this clarification from the manager perspective. When I'm there with the team, I'm using a tool, of course, because it's impossible to read the whole source code. And I'm using a tool which is called Sotograph. There are many other tools out there, professional tools, open source tools. I can give you lists of names if you want. I'm an expert in this tool, so this is why I'm using it, because I'm very, very, very quick with it, and this is what you have to be if you do a mob analysis. So, but it's not about the tool here, because this is just the help, it's about what we can learn. So this tool is a commercial product since 2002. It's used by many companies, and can do analysis for Java, C#, C++, ABAP, and PHP, and other languages that I have seen as well. And it works like this, that there are different parsers that parse the source code and copy the structure into a database, and from this database you can look at it with different tools and views and see the structure of that program. And you can have several versions of it and compare the version of last week, of this week, what architects like to do. And now I will show you how this works so that you have a sort of an idea what I do in those meetings. And now it gets complicated because Wolfgang has to hold the microphone for me, and whenever he takes it away, you have to tell him not to do that, okay? Okay, so. I have brought with me the source code of Wordpress here, because I have to take, of course, an open source system to show you something. I can't show you any company code, that's clear. Okay, what do you see here? You see here sort of a tree. This is the directory tree of WordPress. So there's a WordPress directory, and inside there's a VP content directory, VP admin directory, and you can open those directories and find the subdirectories, and finally you find files. So files are shown like this, like triangles, and you can even go into the source code if you want in this tool, which is important if you use tools like this, because you want to drill down and see what is causing a problem in here. So this is the thing with the round bubbles. The ones which are darker, there's more in there. So they have more siblings in there. And then they have these arcs here. So what's about these arcs? Well, an arc on the left side here means that they're up here in the VP content directory, there are some files that need something from down here. We will have a look at that. I can click on one of these arcs and I will have a filter and just see that part of the system that is responsible for this connection. So you see here is a file called class admin PHP, and in there all these other files are used, and we can directly jump to the line in the source code where this use happens. So this file is using them down there, and the other direction is the way upside down. So something from down here is using something up there. So this is the whole secret of this view. So if you see something like this, you see already that this is sort of a tangled monolith, don't you? You can see that, can't you? Yeah. So anyway, as an example, I will try to show you what I mean when I say we model the architecture on the source code, onto the source code. So what I will do now is I will create, now you have to help me, I will create several layers for in the first place. I have to see that thing down there anyway. Okay. It's a bit difficult, but it's the best we can get today. So here now, I will ignore this part down here. So now I have created a first vision of the architecture, imagining that the architect told me, oh, no, I go back to the former view. What you see here are our 4 layers, okay? I have created 4 layers, as you can see, and layers in this tool and in all other tools which are similar like that, of course, come up with that connections from down here up there are forbidden against the layering. This is not a good idea, so they are red, and we can start to inspect those problems. We can, for example, have a look at this one, and here we have several relations from down here up there, and now the fun part starts, because we start to think about a refactoring for this. And we will have a look at this function functions PHP file. It is used from down here, from the admin part of the system, and let's just assume that the architect tells me, well, maybe it's wrong up there, maybe the functions PHP, it belongs down there. And what we can do with this tool is we can simulate refactorings. And this is how we start to change the system and have a look how the system should be like. So one idea I could have is I could have the idea to move this file down here. But before I do that, I have to find out if this really helps the architecture, because here I have only a filter on the system. So what I will do is I will extend the view with all the dependencies of this functions file. And now you see all the classes that are related to functions. And if you look very close, you see that here is a little error. What does it mean? It means that functions uses something from here, from this inc directory. It uses the customer PHP. So what would happen if I move functions down there into the include layer? What will happen? Will it be better? No, it will not be better. I will show you what will happen. I take it. This is magic. It's my fingers here. Poof. Now it's down there, and you see it doesn't help much because I still have this error because functions is using something up there. So let's have a look. Maybe we can do something with customer too, but same procedure as every year, James. We have to find out if customer needs something else. So what do we see? Customer needs custom header PHP. Okay, and custom header PHP. So where's the end of the story? We have to find out. No, nothing more. So what can we do? We can really move these two. Now help. Yeah. Move these two. And this time I will really move them because I want them to be in this directory down here with all its friends. So I really take them and put them in this directory here. And what happens now, if you have good eyes, you see the little R here down here. Do you see that?
Yeah.
And this means that these two classes are refactored. They are moved to another place. And when we do this a lot to get an order into a system, to reorganize the whole system, and then we can create a report afterwards from when I do it the first time, the people look at me and say, "Oh, didn't you do this in our system?" And I say, no, it's just in the database here of the tool. If I do it 10 times, they say, "Oh, could you maybe do it in our system?" And then I say, "No, I would never do that, because you have some automated tests and they have to run, before anybody does that. So you have to put it in your Jira or whatever you use for technical devs, and you have to in your backlog and work on it."
So what is it good for? My chief developer, who developed my original system, is not available anymore. He left the company some years ago. So I have about 1 million lines of PHP code. And there are people who have a rough idea what the architecture should look like. Unfortunately, it's not what is in the code. Now, I can at least try to model together with them what the architecture should have looked like. And then we can figure out, can we refactor so it adheres to what they originally intended.
And this is what I do all those days with teams. We sit in front of their system, like you have seen just then with Wordpress, and we restructure, we find refactoring. Sometimes, of course, if we find a file that should be divided into 2 files, a class that is too big, or a method which is in the wrong class, then we can't do it in the code. We take a picture, we write down what has to be done in that case. And the 2 goals that I'm trying to follow with this approach is, on the one hand, maintainability. So I want people to have a system that is in order, so they can find bugs quickly and they can do quicker changes, so they understand quickly what is happening in the source code. And the other thing I want to divide systems into flexible components, into modules or into microservice, whatever you want to name them, because I'm running into a lot of monoliths these days with many lines of codes, and they need to be cut into pieces anyway, So this is what we can do here. And now I want to tell you why I'm doing all that. I'm doing all that because there have been, I have done some experiments with my colleagues, and there are many papers about it. Where do we spend our time, we programmers, when we write code or when we have to solve a problem? What do? 70% of our time we spend on reading code, on reading and understanding and remembering and finding our way around. 20% on problem solving and only 10% on real programming. So the area where we can save time is here, in this area of reading. And what can we do in this area? I have been writing a doctor thesis on complexity of software architecture, and there I had a look into cognitive science. And the cognitive scientists, they have found different mechanisms that we have in our brain that help us to deal with complex structures. So our brain is prepared to work with complex structures. The software just has to conform with it, to go in the same direction as what our brain can understand. And there are the three mechanisms that we have in our brain to help us to find our way in complex structures. One thing we do is named chunking. One thing that we love, that our head loves, are hierarchies. And one thing that we can do is called schematas. And I will show you very quickly what this means. Chunking means that you're the whole time summing up, adding little things together, little chunks, and creating bigger chunks out of them in your head. This is what you do the whole time. You have about 7 places in your short brain, and my sentences are much longer than 7 words. So you're actually chunking the whole time, otherwise you wouldn't understand anything what I say. So you're doing this the whole time. And this only works when the things that you are chunking mean something connected. So it's not about being close to each other, it's about being something that belongs together. Only things that make sense together can be chunked. So this thing, you can't chunk it. I mean, maybe you think beach or something, this could be the case, but it doesn't really help. Or if you look at me, you think, oh, a speaker, you know? But if I would have a water pipe here, you would have a problem to chunk me. What am I, you know? So things have to be related with each other to be chunked. And in computer science, we have a very good principle that reflects this idea, and it's already very old, and we had it already today. It's called modularity. But this is the real sense of modularity, to create something which is a whole, which is connected. It's not about putting things together that don't belong together. It's about putting things together that belong together. Na gut.
Okay, you remember my slide with showing how our business is structured? So we have a top-level process that has 4 sub-processes. On the level below, we again chunked into smaller process pieces in that 4 big business domains. That's exactly what the target architecture should look like in our place. It can be different than yours, but we applied chunking.
Well, to give you some good time, I have another comment for you. Nobody knew what's in this big and messy class. Therefore, we decided to refactor it. You renamed it to Area 51? Exactly. Well, it's a big and messy class, and at least they gave it a proper name. This is one of the things. If you can't give a class or a file or something you want to have to be a whole, if you can't give it a proper name, it is not good for chunking and it's not modular. So this is for anything, or for classes, for packages, for whole systems. This is true. And this is true for our brain as well. We have wonderful principles in software development. I really love the single responsibility principle from Robert Martin, you might know it. So this is a very good indication for that. Hierarchies. Our brain prefers things that are hierarchically ordered. We prefer to learn things when there are upper nodes and some things which are more special and again more special. We don't like to learn things which are like nets. They have done many experiments on human beings, and this is how we end up. We need hierarchies, so what I need in software systems is some layering, and we will see that, oh, it's not correctly written. Well, and the best thing our brain can do is schematas. In your mind there are many schematas. You have a schemata for houses. If I talk about my house in Hamburg, you will imagine something with doors and windows and a heating system and a kitchen. So you have an idea how houses work. I will show you the power of schema by some examples. If I tell you my parents are both teachers, or have been teachers, the teacher schemata in your head will start to work, and some of you might think, this is why she's talking so much. Or some others of you might think, this must have been a horrible childhood, or something like this. So the pattern is working in your head. Well, now I have to use a German word. I'm sorry for the English speakers, because I don't know the English word for it. Maybe there even exists none. But anyway, on the English speakers, this will work too. If I tell you my father, his job was to be a Säumer, there's nothing. You don't know. Well, maybe someone knows because, a Säumer. A Säumer is someone before industrial not revolution, but before we had trains and trucks and all this, the people who were transporting the goods across the Alps on the Säume of the mountains. This is how the German word for it is. And this was a name for a job. But you remember, it's not about this job, it's about you did not have a pattern for that, so you had no idea. This is what happens if we come across something that we don't know. And the other thing that the cognitive scientists found out is they tried it out with chess. If you take a chessboard and put the stones on it and hand it over to someone who knows chess and tell him to look at it for 20 seconds, take all the stones away and please rebuild it, and you do it with someone who doesn't know chess like me, the outcome is someone who knows chess can reproduce 3 times as many stones as me who doesn't know anything. But only as long as the setting of the chess stones is a regular, has sense in chess. If it's nonsense, we are all the same. Nobody is better. And this is because of those schematas. The experts in chess have a lot of schematas about chess, and they can reproduce much more. And this is something we have in software too. We have pattern. You know that. We have design patterns. And this is so important and has so much value in software that we really have to use it as much as possible. And we do have to use this in a consistent way. It doesn't help much if each programmer has his proper patterns and uses them in his part of the system. The other day I was in a company and I told them, you have like 30 patterns in your system. This is a bit much. You should reduce them a bit. And on top, this part of the patterns, I had to ask that architect, and on this part I had to ask another architect. And the main architect, the chief architect, looked at me and said, we can't reduce them. And I said, why? And he said, listen, our programmers, they are artists. They have to invent new patterns every now and then, because otherwise they wouldn't work anymore. They wouldn't enjoy their work, they would stop programming. So we have to, our software has layers of patterns in it, like a tree, if you cut it in pieces. I'm sorry, I know a lot of software systems have slices of different versions of patterns, but it's not a good idea. Imagine you have to find a bug and you have to work your way through all these layers of different types of patterns to find out what to do. This will, of course, not help you to be quick. And this is the question. You remember the question was, how can I quickly change something in the software and find a bug? This is why we need all this. This is what our brain helps us to be quick. And now, now it's 10 past 10. Do you want to go home? Do you want to see some examples? Yes. Okay, who has to go home just leaves, okay? And we keep on having some fun here.
You see, I get the microphone. I don't have to ask for it. We started with a picture containing the business processes, the different services, and that was one of the views. This is now actually really one of the implementation views we have. So we applied exactly what Carola said. We have different layers, and we have two types of layers. So one is really structuring against technical capabilities. Of course, we have a data layer with an ORM model. We have a domain layer, which contains pretty simple services. They contain business objects. Then we have the business process and activity layer. That is where processes are implemented and service orchestration takes place. And we have the presentation layer, where different applications on top of our services are built. So that is actually how the architecture from that view looks like. And then there's the other view, and this is pretty important because that's how our business works. We have domain layering. So across that line, we again find our value chain. We have offer, order, contract, return and remarketing, and there are missing 2 or 3 more domains we didn't model yet because they are in the old code. We have an idea how it should look like, but it is not built into the new applications. And so we need both types of layering really to understand the complete picture. And this model, the domain layering, is pretty important to talk to our business people. And so therefore, we would like to have a way to model that on some kind of tool layer too.
And I will show you now how Wolfgang's system would look like if it would be in a good state, okay? So this is an example. You have seen those arcs already, so you know the left side is good and the right side is not so good. And this was a system I saw the first time. It had 170,000 lines of code, and they wanted to do some enhancement. And when I saw it, they didn't have a proper technical layering, so I worked on it with them, and I told them, well, I come back after the enhancement in a year, and then I want to see a technical layering and a domain layering. And they said, ooh, and they did it. And here you see the very good result, what they did. You see the layers here. This is the basic data. So this is the basic technical layer, the database connection. Then there is some other basic stuff. Here is some domain. Here's the application layer, and up here is the user interface layer. This is just what Wolfgang showed us before. And well, the darker ones, there's more in there. You know that already. And there's a red one, which is not so good. There's something from the application layers using something from the user interface. And I remember Wolfgang's architect who said, oh yes, I'm so sorry, it's the reporting component. I knew it. We had bad feelings about it the whole time. Here we can see it. And the yellow ones, these are mistakes that are very easy to repair, but they are 3, and this is what happens often. Someone is doing a little mistake, not using an interface or whatsoever, and then someone else comes around, we can do it that way, and he copies, and then the next one comes and he copies, and it goes on, and after a while you think, oh, this is how it should be. So this is something we really have to take care of when we see it the first time. And then we took all those components and organized them again from a domain layering perspective. They are the same system, the same components, and down here left this domain layer, and there's a small one, another one. So here you see the domain layers, and I was very proud of that team. Of course, it was not Wolfgang's team, I'm sorry, it was just a story. But anyway, I was very proud of that team because they really did a good work. Now I'll show you that example. This is the technical layering. Well, it looks good, no? Not many red arrows, not many red arcs, but if you have been listening to me very with open ears, you will remember that things which are dark, there's more in there. So here you see something with a lot of things in there and other things where there's not much in there. So this one, I think the mess is in there. The mess is inside. But, okay, technical layering. And, well, these are 90 components, 90 domain components. Well, without any ordering. I didn't do a layering at all. It's just a graphical organization here. And, well, this system is pretty huge, and it's deployed 5 times a year on a weekend, where everybody has to come, all the programmers, all the users, and they all have to test the whole Saturday. And if they are lucky, they will deploy Saturday night. If they are not lucky, it ends up on Sunday. And I asked the chief architect, well, what's your emergency plan? What do you do if it goes wrong? I mean, and he said, we only work with our faces into the future. We don't go backwards. In German, he said, wir haben eine Vorwärtsstrategie. Sounds pretty cool, but, well, no. The whole thing can only be shipped in one component. Only one thing can be shipped. If there's a mistake which is so bad, you can't deliver anything. That means that you will not ship anything. And this is something you can't do to your users. I mean, you can't, it's difficult to decide that as a manager. So we decided to work as long as necessary to finally ship the software. We have that as well on the class level. I just show you some horrible pictures that you can understand why I don't want that. This is another system that I saw the first time when it has 119 classes from 4 components all connected with each other. So you can take this class here, you can pull, and the whole rest will come with it. You can't take anything out. After half a year, it looked like this. And, I mean, of course, the layout is done that way, that those classes which are needed the most are in the middle. And this is why I call them dark holes. But they are really like this. Imagine your boss comes around and tells you, Wolfgang, please, implement another blue one here, please. What will you do? If you're lucky. You copy an old blue one, you change it, and you're in there. This is what happens. This is what happens with monsters like this. Don't do it. The one thing that always helps if you don't have a tool to do these wonderful pictures is to start to program unit tests. Systems that have a high coverage with unit tests tend to not have these things. Please do that, okay? Well, now I will show you some wonderful things I find from the modularity point of view. I very often run into systems that are built like this. People tell me, yeah, well, we have 9 components, 9 whatsoever, Maven modules in Java, or whatever you have in PHP. And then I look at it, and what do I find? I find a big thing and a lot of little things. This is not worth it. You know, this is no modularization at all. You can just forget about it. Huh? You don't do that. I mean, it doesn't really help. You know, there are no cycles. Oh, isn't it cute? Well, it doesn't help at all. Oh, this is another one here. I was in a company, and they had, well, it was a large company, and they had their own platform built with a component model in there, which was done like that no component could live in a cycle. The system wouldn't compile if there would be a cycle between components. And I had the chance to look at 1.5 million lines of code, and I had understood this idea about components, and I asked the architect, well, how many components do you have? And he said, we have 9 components. And I said, well, where are they? And he said, well, could we please do it in the right way? And I said, what do you mean? And he said, well, actually we have 17. Oh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There they are. 17. But there are only 9 components. 1, 2, 3, 4, 5, 6, 7, 8, 9. This one has 80% of the source code. And you see why, don't you? There are all those cycles in there. They couldn't. They built that part of the system before the component model existed, and they end up here. And he said, could I please have that picture? And I said, yes, of course, because then I can go to my manager and explain him why I need money for refactoring. Because before he said, well, you have 9 components, better than 1. I mean, what's your problem, you know? Here you can see, that's the problem. Okay, patterns. Patterns are wonderful. The first thing I ask you to do, I ask you to have patterns in your large architecture, patterns like this, for example. Oh, we have a green module, we have a purple module, an orange module, and a blue module. This is already a pattern, because you give names to part of your software. And then if I ask you, we just do it on a directory tree to make it simple. I ask you to show me where to find this pattern in your software. And we end up like this. If we end up like this, here is the green one. I mean, this is the uppermost directory, and then comes the company name. And so here's the green one, here's the blue one, here is the lilac one, and here is the orange one. This is not a good idea. The pattern of the architecture cannot be easily found in the system. If you have several projects, it's the same question. What would be good would be something like this. You see, you find the pattern in the software. This is important. So this is on the big level. On the level of classes, we have design patterns. You all have things like this. If you do domain-driven design, you have them 2 services, entities, domain values, aggregates, repositories, whatever. Yeah? You have one of your controller probably, or whatever you use in your software. And this is the most valuable thing you can do to your teams, to have a proper set of patterns. And this is something you can check with a tool like this too. You can check whether the patterns are used in the right way. Because what do those patterns do? Those patterns not only give names to classes, so they do something for modularity, because a service has a different responsibility than a business object, but they tell you as well something about the hierarchical connections between those classes. I often come across that when I do the technical layering, and some of the developers or the architect says something like, what's that? A business object is not supposed to call a service. You hear it? You hear the patterns in there? A business object is not supposed to call a service. What does that mean? That means that there are rules about how classes should work together. This is what patterns do. They give us rules how classes should or should not work together. So a business object should not call a service should not call a view or a controller whatsoever. The call direction is here. So patterns do something for our schema idea, they do something for hierarchies, and they do something for modularity, which is really perfect. I'll show you a good example. This is the server component of a system, so there's no UI up here, it starts with services. And what we have done is we have collected all classes with the name service in them. And they are up here in this layer. And we have collected all classes that are named processors, importers, and so on. And often I do it like this. I do it on a board before to find out what patterns are there, what relations they should have, and it's not much red, a lot of green, that's good. And 90% of the source code could be collected in those layers. The 10% rest is often the mess, I told you before, didn't I? Which doesn't conform to the pattern, because those classes, nobody really knew what to do with them. What are they? Where do they belong? And this is the problem. And there are not many violations, which is pretty good. This is a bad example, or, well, this was an interesting case because they didn't know that they had a pattern language. But we digged it out, and we could put 80% of the source code into patterns, they are behind here, and 4% of violations, which is not much. So if you have something like this, if you have patterns in your system, it's like a treasure. You have to work on it and try to make it better and try to make everybody know about it in your team. It's really, really, really a very helpful story for everybody who programs in your team, because your programmer, they don't program layers, they program classes. And there they need those patterns. So we slowly get to the end. Do you think I should show it, or you want to say something?
Yeah, one thing.
Yeah, no, okay.
So with respect to the patterns, you saw my big picture with the 2 dimensions of layering. And of course we have rules, how to name classes, how to name packages, what to put in which level, and even check on that level. But what to do with all the old code? Because there were some rules. And again here, that type of tools are pretty useful because you have an idea what the service layer was. You might have different rules for naming it, but you can just introduce a new layer in the tool and define regular expressions to assign classes with other types of names to that layer. And that's really a diamond.
Diamonds are your best, are the girl's best friends. No, this one doesn't be honest. Okay. So, what I want you to remember, you have not many places in your head left, I think, because I was talking so much. But please remember, do systems that are modular, have some layering, and look at your pattern. Find out if there are some, and if you have a unique language of patterns, and if you can use it and discuss it with your team, because this is really something that helps a lot on the overall structure and on saving time on understanding the source code, because this is where we came from. I hope you remember. Okay, so I hope you don't end up like this. And the last comic: there is not a wrong architecture and a right architecture. Yours is just bad and mine is good. Well, I hope you don't end up like this neither. But you end up with a vision for the whole team of the architecture. And tools can help. There are a lot of tools open source. There are some tools like this one that cost money, of course. It depends on what you want to do. Thank you very much.